So far, we have seen the importance and scope of chemistry in our daily life and how the chemistry plays an important role in improving the economy of our country. So now we are going to learn about the nature of matter. Nature of matter is the chemistry had to deal with the atoms and molecules, right? So there are different molecules and atoms are present. So we have to uh, we have to um, we have to study about the nature of matter. So we are already familiar with the name matter. So what is the matter? Matter is anything that occupies space and have particular mass is known as matter, right? So anything which occupies space and have their particular particular mass is known as matter, right? So matter can be anything that occupies space and a particular mass. For example, if we see around us, an example is pencil. So pencil have particular mass, as you know, and it is occupying particular space in a particular room. So we can say that at that particular space we cannot put anything at that point, right? So if the pencil is placed above the table, right, at a particular area, we cannot place anything at that area. If we remove that pencil from that particular area, then we can put anything at that particular area, right? So we can say that pencil has a specific mass, right, and it occupying a particular space, right? So we can say that pencil is a matter. You can think about we can think anything that occupies a mass and that occupies space. So for example, a bed is an example of matter. uh, gases also occupies some volumes, right? So they are also a matter. Locks are also a matter. So whatever we see around us which occupies a space and have a particular mass is known as matter, right? So now we are going to learn about states of matter. As we are all familiar with the states of matter, the matter could be present in the form of liquid, in the form of first solid, second liquid, and third is gaseous molecules, right? So we have to see some of the properties which are shown by these states of matter. So uh, so if we have to differentiate between these three states, we can say first we will talk about the intermolecular forces. What is the intermolecular forces? The forces acting between two molecules or two atoms. So as we know that the atoms combine to form a matter, right? So what is the intermolecular forces? Intermolecular forces inter intermolecular forces. We have to compare intermolecular forces between these three forms. So if we talk about the solid, we know that solid could not be bent, right? Solid could not be bent, and it is very hard to uh, break apart, right, as compared to liquid and gases. So we can say that the intermolecular forces between the atoms present in the matter is very high. So the intermolecular force is very high in solid. Okay, so intermolecular forces is solid high in solid. In case of liquid, so if we say in case of liquid, the intermolecular forces is little decreased as compared to solid, but is higher than gases. So we can say that the intermolecular forces is little lower if we compared with solid. So forces is medium we can say, right? Medium or low as compared to solid, right? So, and if we talk about the liquid, what is the intermolecular forces between liquid? As we know that the gases could occupy anything. If we provide any volume to it, it can be it can fully occupy that whole space, right? If we put that gas in a small beaker, it will occupy the small beaker space. And if we put that gas in a room, in a high volume room, then it will be occupying the whole room as well. So we can say that the intermolecular forces is very less, therefore therefore they can occupy whole volume, very less, right? So these are the three difference these are the three difference if we are taking if you are taking intermolecular force as subject, right? Now we talk about the intermolecular distance. Intermolecular distance. So we can see that if in a solid the intermolecular forces is high, what does it mean? The arrangement of solid or the arrangement of atom in a solid is very compact, right? So we can say that the intermolecular distance between two atoms is very low. If the intermolecular distance is very low, then the intermolecular forces will be high, right? What I want to say is, if two atoms present here, what do you see here? The intermolecular force between these two atoms and between these two atoms, what do we see here? The intermolecular distance is very low as compared to this one. Therefore this is arranged compactly, and this is very high strength in bond formation. So we can say that in a solid they are compactly arranged, therefore their intermolecular distance is very low, right? So what can we see here? In solid the intermolecular distance is low, solid low or less. Okay, if we see intermolecular distance in case of liquid, what do we see here? We can see that if we pour any liquid at any container, it occupies the whole space, it occupies the container space, right? So we can state that the liquid is flowable, right? Flowable. So the arrangement of atoms is very mediumly arranged. The intermolecular force is medium as compared to solid, or we can say the intermolecular forces is intermolecular distance is higher as compared to solid, right? While in case of gas, as I told you that if gas is put in a particular beaker, it occupies the space of beaker, and if it is placed in a room, then it will occupy the whole room's volume, right? So we can say that the intermolecular force in a gas is very high. Intermolecular distance is very high. So this is the two main thing in if we take intermolecular distance as a subject, then we can say that the solid has very low intermolecular distance, while the liquid is a little higher as compared to solid, and as in case of gas, it is very high as compared to both of them, solid and liquid. So if we talk about the volume, if we talk about the volume, shape and what can we see here? Volume and shape, right? So in case of solid, as the atoms is arranged compactly in case of solid, so the shape is very rigid. Shape is definite, or we can say definite, and the volume of the solid is also definite, right? While in the case of liquid, what do we see here? The shape of liquid could be changed, right? So if we pour a liquid in a beaker, a triangular beaker, it will change its shape to a triangular shape. If we put that triangular shaped fluid, if we put the liquid in a rectangular shaped beaker, then it will occupy the beaker's space and become rectangular in shape, right? So we can say that the liquid shape is indefinite. Shape is indefinite. We cannot define the liquid's shape. And while the liquid's volume, if we have 1 liter of volume, 1 liter of liquid in a 1 liter of beaker, then it will occupy the 1 liter of beaker. If we have 2 liter of beaker, but 2 liter of if we have 2 liter volume of a beaker, but we have 1 liter of a liquid, then it would only occupy 1 liter of beaker's volume, right? So we can say that the volume is definite. What I want to say is, if we pour in a liquid, let's suppose this is a liquid, if we pour that liquid in a triangular shaped container, if we fill that container with the liquid, then it will what is happening here? The liquid is contained in the triangular shaped container. If we put that liquid liquid in a particular let us say a square shaped container, right? If we put that thing in a square shaped container, then liquid will get the shape of a square. Okay, so the volume is indefinite, right? Volume is definite, but the shape is indefinite. Here we have seen the shape is indefinite, while the volume is definite. While in the case of gas, if we put the gas in a whole room, then it will occupy the whole room. If we put that particular gas in a triangular shaped container, then it occupies the whole small volume of container. If we put gas in a rectangular shaped container, then it will occupy the whole rectangular shaped container. So here we can see that the shape is indefinite. And volume is also indefinite. So here we have seen the difference between the state of matter in by taking subject as a volume, shape, and what have we taken, intermolecular force and intermolecular distance. Okay, so now we see a small phenomena between these three state, that is liquid, solid, and gas. The state could be interchanged between these three state, है ना. The if we provide heat to a solid, let us suppose example of solid as a what do we take? Ice. Let us take ice as an example of solid. If we provide heat to that solid, the intermolecular distance will get higher, and the arrangement of that arrangement of the atom will become loose, right? So it will be transformed into liquid, right? If we again continuously providing heat to that liquid, then it will be converting to gas. So the intermolecular distance is very high as in gas. If we provide heat to liquid, the intermolecular distance will get higher and it will transform to gas. If we take energy from the gas, or we say if we provide coolness, if we decrease the temperature of gas, then the molecules of the gas will come together and will transform into liquid. And this process so first, if solid is converting into liquid by providing a particular temperature or providing it energy, this is known as melting point. And if we're providing energy to that liquid, and if that liquid is transforming into gas, then this will be known as boiling point, right? So gas will condense to again liquid, liquefaction, and that liquid, if we again continuously lowering the temperature, the atoms will come closer and become solid, and we will get the solid. So another thing one thing has to be noticed here is the sublimation. So what is the sublimation? Sublimation is a process in which the solid particle directly converting into gas. Solid directly convert into the gaseous phase. Then this process will be known as sublimation, right? So if you want to classify the matter, how can we classify the matter? The matter could be classified. Classification of matter. If you want to classify the matter, it can be further classified into mixture, and another thing, pure, right? So how can we define the mixture? And how can we define pure? When the chemical properties of constituent particular when the chemical properties of a constituent element or compound is same, then it will be called as pure matter. For example, H2, O2, glucose. These are the examples of pure matter. And another thing is mixture. So what is mixture? If we put two or more than two pure matter in any ratio, if we put two or more than two pure matter in any ratio, then it will be named as mixture. The mixture can further be let us take example. Example could be oil plus water. They have different chemical property and they have different chemical property. If the chemical property is same, then they will be known as pure. The both of them are pure, right? If we combining this pure, then they are forming mixture. Okay, so mixture is a, how can we define mixture? So the mixture is a combination of two or more than two pure matter. Okay, so example of mixture is oil plus water, or we can say soil plus water. Okay, so these are the example of mixture. So here we can again classify these two things, mixture, into homogeneous and heterogeneous. Homogeneous and heterogeneous. Okay, so what is homogeneous and what is heterogeneous? If the combining components get mixed with each other in, if the combining components mix with each other in if the combining components mix with each other and we cannot separate them physically, then it will be known as homogeneous mixture. Okay, so alcohol C2H5OH plus water, if we combine these two different pure matter, then it will form homogeneous. Why? Because we cannot separate them physically, right? And while in the case of heterogeneous, the component which are getting combined can be separated physically. Example is soil plus water. They could be separated by using physical method, but in case of homogeneous, it could not be separated by using any physical method, right? So in case of homogeneous, they are completely mixed with each other. This means that the particle of the component of the mixture, the component of the mixture are uniformly distributed throughout the bulk of a mixture, while in the case of heterogeneous, it is not uniformly distributed throughout the bulk. Okay, so and we can separate the heterogeneous components by physical method, but in case of homogeneous, we cannot separate the components by any physical method. Okay. Now we have to classify the pure material, pure matter. The pure matter could be further classified element, and another thing is compound, right? So what is element and what is compound? As per the name, element is when the constituent constituent matter is only one type. When the constituent matter is composed of only one type of atom, then it will be named as element, right? So example of element is gold, silver, copper, zinc. So they are the example of element, right? So we cannot separate this particular element further, right? So we cannot separate gold, because it's a particular element. We cannot separate it further, right? And similarly, silver, we cannot separate silver further. This is a pure element. So example of elements are gold, silver, copper, zinc. When two elements combine in a particular ratio, then they will be forming a compound, right? So example of compound is H2O, C6H12O6. The both of them are example of compound. And the definition of the compound, we can write, when two or more than two elements are combined in a fixed ratio to form a particular compound, then it will be known as compound, right? The example is water and glucose. Here the two elements are combined, hydrogen and oxygen, while in case of glucose it is combination of carbon, hydrogen and oxygen. The three elements are combined in particular ratio, then they are forming a compound. Okay. Compound could be in the form of heteroatoms. So here we can say that the compound could be in the form of heteroatom. It could be in the form of heteroatom, and or it could be in the form of homoatomic. So what do homoatomic? So what do we see here? As per the name, heteroatom means two different elements are combined to form compound. For example, heteroatom CO2. Carbon is a different element and oxygen is a different element, and they are combined in a fixed ratio. So this is an example of heteroatom. Similarly, in case of homoatomic, when two similar element are combined to form a compound, then this will be known as heteroatomic. So example of heteroatomic is O2, H2. Here we can see that the oxygen, two atoms of oxygen are combined to form O2 molecule. This is homoatomic. Here two atoms of hydrogen combined to form H2. This is homoatomic. So these are the example of homoatomic, and CO2 is the example of heteroatomic. Okay. In upcoming video, I will be talking about properties of matter and their measurement.